Welcome back to AS online platform. Myself, Vamshi Krishna. My dear students, in the yesterday's session, we have discussed the preparation strategy in our discrete mathematics. We did deep analysis about questions and some concepts and everything. In today's session, in this today live session, we are going to discuss some important concepts in the area of discrete mathematical structures. Let us go through the algebraic structures, that is monoids and groups area. In this area, we are going to discuss some important concept. As I mentioned earlier, the trending of the group theory is going to be changed actually. So once upon a time, how we are getting the questions from generators and algebraic structure, binary operation, how it follows the some properties. So now the trending is like this. They are framing a question, which of the following statements is true or false. And in that statements, they are asking about the group properties, right? I hope you remember yesterday's lecture and everything. Let us move on to the topic, and we can discuss some algebraic structures. Yeah, my dear, we have algebraic structures like this. The definition of algebraic structure is a non-empty set which is equipped with some operations and it can also follow some properties. That set is known as algebraic structure. What are the properties? That properties we can discuss. And depends on the properties it can follow, we can name it as groupoid. Yes, we can name it as groupoid and a semi-group, monoid, we can say group, and abelian group or commutative group like this. Yeah. Before going to the classification of algebraic structures, let us understand the properties of an algebraic structure. Algebraic structure may follow some properties. I am not saying that every algebraic structure follows these properties. If our algebraic structure follows some properties, according to that we can call that algebraic structure as with a specific name. But before going to that classification, let us understand what are the different properties available. Is my point clear? Yes. Yeah, let us take it. Closure property. Here we have a closure property, something like this. For all AB belongs to S, for all AB belongs to S, let us suppose S is the given algebraic structure. For every pair of AB belongs to S, you can take any pair of elements in S, A star B must be belongs to S. So star is the binary operation there. A is any element, B is any element in the given algebraic structure. I operated the two elements with binary operation called star. So I got A star B, and A star B must be belongs to S. If it happens, then I can say that the given algebraic structure follows closure property. Yes, sir. Yes under star follows closure property, or you can say that yes star is closed. Fine. And associative property, we have associative property like this. Let S be the given algebraic structure for any triplet, for all A, B, C belongs to S. Right, sir? A star B star C is same as A star B star C. My dear, the associative property says that the order of the operation doesn't matter. Yes, you can do A star B first, and later you can go for you can do B star C first, whatever there in the bracket. I am talking about this. B star C first, and after that you can take A star B star C. That is same as A star B star C like. So it follows like this. Then we can say that the given algebraic structure follows associative property under the binary operation star. Right? And in similar way, let us take identity property. If we go for identity property, let S be the given algebraic structure. There exists some E belongs to S. There is some element E belongs to S, right? For every element A in the S, there exists some E in such a way that A star E is equals to A and E star A is also A. For all A, for every A, for every A. Sir, you can take any element in the given algebraic structure. There exists some element which is called identity element E. That E exists in such a way that A star E is equals to E star A is equals to identity like. Right? That is the property of identity, my dear. Closure, associative, identity. Next, let us move on to the something property called inverse and commutative. We can discuss such properties also. Sir, inverse property says like this. For every element in the algebraic structure, there exists some element in the same algebraic structure. For all A belongs to S, there exists some B belongs to S. For every A, there is some B. For every A, there is some B. So multiple quantifiers, order of the quantifier matters a lot. For all A, there is some B. There is some B for every A, it is different, right? So for all A, there is some B such that A star B is equals to identity and B star A is also identity, and you can say that A star B into A star B is equals to B star A, and which is equals to identity. And from this definition you can understand that without this we cannot define the inverse, right? Without an identity element, then don't talk about inverse. So if you want to specify the property of inverse, so we must require identity first. A star B is identity, na? B star A is also identity. Then B and A are said to be inverses to each other, right? Yeah, the same thing I want to write in some other vocabulary like this. Can I say like this? X star Y is same as Y star X and which is equals to identity. If it happens X star Y, Y star X is equals to identity, then I can say that X and Y are inverses to each other. X inverse is Y and also Y inverse is X. Right? Inverse property. And coming to commutative property is just like A star B is equals to B star A. Yes, sir, A star B is equals to B star A. For all A, B belong. You can take any pair of elements from given non-empty algebraic structure. Yes, you can take any two elements from the set. It must satisfy that A star B is equals to B star A like. Yeah, these are the different properties available, my dear. Let us suppose something like I want to prepare a small example that is called Z, the set of integers with operation called addition, right? My example is set of integers with operation called addition. So if you ask me about closure property, what is closure property is saying? You can take any two integers, one integer is 4 and another integer is 6. And if you operate them with a star, 4 star 6, sir, star is what here? Star is nothing but addition in this particular example. 4 plus 6 is equals to 10 and 10 is also belongs to the same Z, which means that the addition of two integers is again results an integer. So what I am trying to convey here, A star B is equals to S for every AB. If you take any pair of elements, A star B must be belongs to given S. And in similar way, associative property also, you can go for order of the operations. Yeah, I want to take in this way, something called 2 plus 3 plus 4. Yes, I want to do the parenthesis area first. 3 plus 4, 7, 7 plus 2, that is 9. LHS part answer is 9. So it is same as 2 plus 3 plus 4. Sir, it is not only for 2, 3, 4. You can take any set of integers, 0, -5, -7, or you can take -5, 7, 9. You can take any triplet. Definitely it has to follow that 2 plus 3 plus 4 is same as 2 plus 3 plus 4 like. And coming to identity property, let us think about identity. What is identity saying? Identity saying something like this: A star E must be equals to E star A, and which is equals to A. I want such E. Sir, A is an integer. A is an integer, something like 2, 3, 4 you are talking about. 2 plus something results something plus 2 results again 2. What is that identity element? What is that integer exist in your Z? Yes, it must be exist in Z. It should not exist somewhere. It must be present in given Z, my dear. I hope you got this. E must be belongs to the given S, not somewhere else. Right, sir? 2 plus 0, 2 plus 0 is same as 0 plus 2 is 2. And 3 star 0, 0 star 3 is 3 again. 4 star 0, 0 star 4 is equals to 4 again. My dear, I hope you got the idea. A star E is equals to E star A is equals to A. For every A it happens, for every integer. Such integer E exists in my algebraic structure. So you can call that E as an identity element. And we can say that yes sir, identity element exists in the given algebraic structure. 0 belongs to Z, so it exists in given algebraic structure. And my algebraic structure Z under operation plus follows identity property. Z plus follows identity property. I hope you got the example of identity property. And in similar way, let us move on to the inverse property. Sir, if you want to go to inverse property, you should know about identity. Yes, that's fine. Here identity, what I got here, identity element is 0. In the particular example, I am talking about Z under operation addition like. Fine. X star Y is equals to Y star X is equals to identity. So what is star here? Star is the addition operation. X and Y are two integers. What I want to say is 2 plus something results identity. What is that? What is that? Yes, I hope you got it. 2 plus minus 2 and minus 2 plus 2 results identity element 0. In similar way, if your element is minus 5 plus 5, 5 plus minus 5, that is equals to 0. So minus 5 inverse is plus 5 like. Like this, every element is having inverse. And identity element inverse is also itself. E inverse is E only. 0 inverse is 0. In my algebraic structure, every element is having inverse. So I can say that yes, the given structure follows inverse property. A star B is equals to B star A is equals to identity. For every A, there exists some B in this way. So we can say that it follows inverse property. Right? And coming to what do you call commutative property? What is commutative property? So the operation of addition, even if you change the order, no problem at all. If you take the example just like 2 plus 3 is same as 3 plus 2. This is very simple example, my dear, addition. So in place of addition, you may have concatenation of strings operation, or you may have matrix multiplication, you may have XOR operation, or you may have some other operation, something like they can define a own delta. X delta Y is equals to X square plus Y square like, or X delta Y is equals to X power Y. So they can define the definition of binary operation in any pattern. In any pattern they can define. So according to that, we should move and we should say that yes, it follows commutative and it should not follows commutative like this. Right? So what is our conclusion? The given algebraic structure Z plus Z under operation plus, it follows closure property, associative property, identity property, and inverse property. Yes, it also follows commutative property, right? These are the properties we discussed with some example. So if these properties are okay with you, then we can move on to the classification of algebraic structure. Now let us see the classification of algebraic structure. The total idea of this chapter I have given in a simple table like this, right? So there is an algebraic structure. That algebraic structure, let us suppose S is the algebraic structure, that S follows only closure property. It does not follow any other property. Yeah, it may follow it, but requirement is closure. It may follow it. It doesn't mean that if it follows closure, it does not follows associative and all that things. If it follows closure property, that is necessary and that is sufficient to say that the given algebraic structure is groupoid. Right? I hope you are getting the idea of the table. Coming to the semi-group means the given algebraic structure should follow closure and associative. It may follow about other properties, doesn't matter. The necessary and sufficient conditions are these. If it follows closure and associative, then I can call that algebraic structure as a semi-group. Fine. And in similar pattern, if the given structure follows the first three properties like closure, associative, identity, then we can call it as monoid. Right? And let us enter into the actual important area of gate, that is called group, when the given algebraic structure is called as group. Yes, sir. The given algebraic structure is called as group. It follows the following four properties. The properties are closure, associative, identity, and inverse. We discussed all these properties right now. Am I right? Yeah, just now we discussed all this. Yeah, closure, associative, identity, inverse. If the given structure follows all these four properties, then we can call that algebraic structure as a group, my dear. Groupoid, different, it's group. Fine. And next coming to subgroup. Subgroup is also a group. Subgroup is also a group and it is nothing but simply subset actually. Let us suppose the set of real numbers R is here. I written R there, set of real numbers. When I written R, set of real numbers, your mind should think like all possible real numbers except imaginary numbers. Positive numbers, negative numbers, zero, fractions, rational, irrational, all numbers should come in your mind. The set of real numbers with operation addition is a group. Am I right? The set of real numbers under the operation addition is a group. And you clearly know that there is a structure called Z. Yes, sir, Z. Just now I analyzed Z. Na? The last example, what I have taken here, Z. Z is nothing but set of integers. Sir, this is Z. So Z follows closure, associative, identity, inverse, commutative, all properties it follows, right? Okay, sir, anyway, Z plus follows something called all four properties. You can call your Z as a group. I will accept that. My dear, you may accept that, but before that, what is my point is, Z is nothing but subset of R. Z is a subset of R and moreover Z is also a group under the same binary operation addition. Sir, Z is a subset and it is also a group. That's why it is known as subgroup. Yes, sir, it is a subset and it is also group. Na? So that's why we are saying that group means it has to follow. Your subgroup also should follow all four properties like closure, associative, identity and inverse. Is my point clear? Fine. And in similar way, let us move on to the abelian group, something called commutative group. When a group is called commutative, if the given group follows commutative property, then it is known as commutative group. Sir, if a given group means the given algebraic structure follows all four properties and also additional property commutative, A star B is equals to B star A for all AB, right? So if the given algebraic structure follows all five properties, closure, associative, identity, inverse and commutative, then we can say that algebraic structure is an abelian group, my dear. It is an abelian group and it is also known as commutative group, right? So this is the total idea of the classification of algebraic structures. And before going to the formal questions, let us move on to the properties. I hope this table is clear to you. Here one property, here two properties, semi-group, half of the group. Group requires four properties, semi requires only two properties, semi-group. Monoid requires three properties here, and subgroup requires same properties, and abelian requires five properties. 4 plus 1 is equals to 5. I hope you got my idea. 4 plus 1 becomes 5. Yes, your Z plus is an abelian group, no doubt. Yeah? Yeah, my dear, this is the given classification. And next I will move on to what do you call properties of a group and all. Yeah, I will check your comments also. If you have any doubt in the structures, I will try to prepare some other example. Yeah, at present moment at top chart, I did not find any comments. Just the students are saying thank you, sir, and all. Okay, fine. So let us go to the properties actually. The first property is the identity element in a group is unique, right? When you are taking an identity element, the identity element is unique in the group. This is the first property, or you can take the statement of the first theorem. And the second theorem is like this: the inverse of each element in a group. So we have a group now. In that group we have many elements we have. So if I find the inverse of any element, that element inverse is unique. Sir, A, B, two elements are there, their inverse is same. Such thing is not allowed. So inverse of A is some X and inverse of B cannot be X. It is something different. So I hope you got my point. So the inverse of each element is unique. Next, the inverse of the product of two elements of a group is the product of inverses taken in reverse order, right? The inverse of product of two elements in a group. I just taken something called product of two elements. So the inverse of the product of two elements is the product of inverses taken in reverse order. So A here and star B here, right? A star B whole inverse, the inverse of product of two elements A, B whole inverse is nothing but the product of inverses in reverse order, B inverse star A inverse, right? So here star is the binary operation, whatever the binary operation available in the question like. So you can also take in some simple terminology. XY whole inverse is nothing but Y inverse into X inverse. So the product in reverse order of their inverses, Y inverse into X inverse, just like this. Right. Okay, my dear, these are the statements we have. So before going to analyzing these statements, I want to prove these theorem statements. Yes, let us go to the proof. I want to take the important one that is called this one. The inverse of the product of two elements of a group is the product of their inverses which are taken in reverse order. Let us understand this one. Yeah, take the proof to this. AB whole inverse is B inverse into A inverse, right? Yeah, my dear, this is the question we have. Now what I want to take is, I want to consider some two elements. In the given group, let G star be the given group. Let G star be a group. When I written this word G star be a group, it means that the given structure follows all your four properties. I covered all things here. G star be a group, and we have two elements in the group. It is given in the question like A comma B belongs to G. And we know that if A comma B belongs to G, which implies that definitely A inverse and B inverse also belongs to G. Why it happens, my dear? Because we mentioned that, so A, B is a, G is a group. G is a group under the binary operation star. Then definitely A inverse, B inverse also present because it has to follow inverse property. So you can say that it has to follow inverse property. Since inverse property, let me write like this. Right. Now let us consider, I want to consider the elements like this. AB star B inverse into A inverse. My dear, the given format is like this: AB whole inverse is equals to B inverse into A inverse. Just removing the inverse, I consider the elements in such a way that AB star B inverse A inverse. Right? So let us operate this. Let us see what is I will get. So what we will get, let us see. Sir, A here, AB we have, and we have some star operation, B inverse, A inverse. When you are writing AB, this is nothing but A star B. You should understand binary operation. And it is also B inverse star A inverse. I hope up to now everything is clear. Now I want to apply associative property. I can remove parenthesis anywhere and I can give parenthesis anywhere. So I just removed the parenthesis and I want to operate first middle two elements like this. Because there is some simplification is possible. That's why I am doing like this. So this step is possible just by associative. So let me write something here. Associative like A star, B star, B inverse, star A inverse, and since the given structure is associative, right? And let us see this. Here we have something like A star, B star, B inverse. B star, B inverse is nothing but identity element, star A inverse here. So this is possible because of inverse property. and which is equals to, again you can use associative, A star E here, star A inverse by associative, since given G is associative, and A star E here, A star E is nothing but A, so that is because of identity property. And in similar fashion, what we have, A star A inverse we got, A star A inverse is nothing but identity. So it is also by, what do you call, identity property. Since identity exists in G, so we got this. Sir, you considered something which is in the form of just like X star Y, and you got identity element. In similar fashion, let us apply just like a commutative Y star X. Yes. Yeah, my dear, I want to consider now just Y star X, B inverse, A inverse, star AB like this. Right, sir? B inverse, A inverse, star A, B. This is nothing but B inverse, star A inverse, star A, star B. This is B inverse, A inverse, star A, star B. Let us operate here. So B inverse, this is identity, star B, and B inverse, star E, star B, and this is nothing but B inverse, star B, and B inverse star B is nothing but identity. Fine. I did in similar fashion. I hope you got the idea. So the first step here, I got something called, it happens because of given G is associative. And A inverse star A, I written as E. This is possible because of inverse property. B inverse star, I just taken parenthesis here. So which means that I used associative here. And B inverse star E is B inverse I have taken. It is nothing but identity property. Just like X star E is equals to X. In place of X, I have B inverse. B inverse star E is nothing but B inverse like. So it is something called identity. And again B inverse star B I got, that is called identity. This is because of our inverse property. My dear, just understand what I have did here. First I considered this part, AB star B inverse A inverse, and after that I have taken inverse part B inverse A inverse star AB, and in both cases I got the result as identity. Yeah, let me conclude something here. Sir, our conclusion is, first you have taken AB star B inverse A inverse, and after that you have taken B inverse A inverse star AB. So in both cases the result is identity. So just to compare, let us compare this. Let us compare this. It is in the form of X star Y is equals to Y star X is equals to identity. If X star Y is same as Y star X and which is equals to identity, you can say that X is inverse of Y and also Y is inverse of X. X and Y are inverses to each other. If this thing happened, definitely this can be happen, my dear. And I think we already discussed this in inverse property. Let us show me that one again. Yeah, here I written something. X star y is same as y star x is same as e. If such x is exist, for such y is exist for every x, I can say that it follows inverse property. And x inverse is y and y inverse is x. So remember that, remember that. And let us apply the same logic here. Yes, sir. This is just like x, sir. This is just like x. And this is just like y, sir. X star y and y star x, and which is equals to identity. So I can write x inverse is equals to y. X inverse is equals to y means my sense is x inverse means here x inverse AB whole inverse is equals to B inverse into A inverse. This is possible, my dear. The product of inverse of the given two elements is nothing but the product of inverses of the elements individually which are taken in reverse order. Yeah, is the logic clear? I considered x star y and y star x, and I try to find in both cases, either in first case I got identity. This is just like x star y. And coming to the second case, here I have taken y star x. In both cases, result is identity, so I confirmed that x star y is an identity like this. In similar fashion, what I want to say is, I can move on to the another theorem statement. So the statement is like this. Yeah, have a look. Let G be a group with identity element E. If A square is equals to identity, if A square is equals to identity, for all A belongs to G, not some A, for every A belongs to G, then G is known as abelian. This is the property of a group, and we want to take it as a theorem, and let us prove this property, right? If G is a group, yes, your G follows closure, associative, identity, inverse, all your properties. And apart from that, it can follow one more condition. The condition that A square is equals to E. A square, A star A is equals to E. It is not for some A, my dear, every A belongs to G. Then we can say that G is an abelian group. Abelian, what is abelian? Abelian is nothing but commutative group, right? A star B is equals to B star A. It follows commutative. It is already group now. It follows already 4 properties. We should prove only one property, that is called commutative property. Yeah, if it follows commutative, then we can confirm that it is called abelian group or commutative group. Yeah, this is the thing we have. This is the data. This is the clue we have. A square is equals to identity. By using this one, we should prove that one. Right, let us move on to this. It is given that G star be a group. Sir, we have G here. G star is a group with identity element E, right? And we also know that A square is equals to identity for all A belongs to G. For every element in the given algebraic structure, it follows that A square is equals to E. Please don't think A square is simply A into A. Here the product means it is the product of binary operation. So A square means A star A, which is equals to E. Can I write like this? A square is equals to A, which means that A star A is equals to E for all A belongs to G. My dear, by using inverse property, we clearly know that If A star B is equals to B star A is equals to identity, then A and B are inverses to each other. Am I right? So I want to say something like this. We know that the given question is in A, na? Let me write in X or something. If X star Y is equals to Y star X is equals to identity, then we can say that X and Y are inverses to each other. X inverse is equals to Y and Y inverse is equals to X. This is the known thing to us. But in similar way, if you observe this is acting as X and this is acting as Y. Yeah, let me write one more time. Sir, here we have A star A is equals to identity, and we know that A star A inverse is equals to identity, which means that A inverse is nothing but A. Therefore, A inverse is nothing but A, not for some A, for every A. A star A is equals to identity. It is for every A, na? It is for every A, my dear, for all A. So, for all A. Here also for all A. Right? So, I concluded something. In my group, every element is inverse to itself. If every element is inverse to itself, now I am trying to prove that G is an abelian group. If you observe my concept, this is a theorem. In this theorem, one more sub-theorem is there. Now I got something like this. A inverse is equals to A for all A. So from this, I want to write a point like this. Now, we have A inverse is equals to A for all A belongs to G. Therefore, which means that in G, in the given group G, under operation star, every element has its own inverse. Every element has its own inverse. If every element is having its own inverse, then I want to proceed to the question. My target is something like I want to prove abelian. When I see this word abelian, something is there in my mind. Yeah, target is A star B is equals to B star A, or X star Y is equals to Y star X. I need to show that one. Okay, let me operate in this way. Sir, every element is having inverse now. Okay, let us suppose, sir, I want to take two elements. Let A comma B belongs to G. If A comma B belongs to G, therefore I want to confirm that A star B is also belongs to G. Sir, how you can say that? Because the given algebraic structure is a closure. It is closed. It follows closure property. It follows closure property means that definitely if you take any two elements, their star operation definitely belongs to the same set. A star B belongs to G. I can say that because given G is closed or because of closure property, since G is closure. Okay, sir. I confirmed that A star B is one element in the given G. And also, I want to say one more thing. Therefore, as A and B belongs to G, I am writing this step from this one, or otherwise I will write it one more time. If as A comma B belongs to G, then I can say that A inverse comma B inverse also belongs to G because our G follows inverse property. At the starting of the discussion, we discussed inverse property, right? X star Y is equals to Y star X is equals to identity for every X in the given G. Not for some X, my dear. Every element in the given algebraic structure should have the inverse element. So in that case, if AB belongs to given G, definitely A inverse B inverse also belongs to G. Otherwise, inverse property does not satisfy, na? I hope you got my point. Now what I operated is, I started that first A star B belongs to G. I confirmed this point. And second point is A inverse B inverse also belongs to G. Are these 2 points are clear? Yes, if these 2 points are clear, just to see how I am going to operate, I want to consider now. Let us consider, my dear, let us consider two elements A and B and operate them A star B. Yes, I know that A star B definitely belongs to G, that is closure property. That story is over. Now my target is abelian group. In my mind, what is working? A star B. From A star B, I need to get B star A. Let us proceed. Sir, A star B is equals to, you mentioned that every element in the group has its own inverse. Every element in the group has its own inverse, which means that A inverse is equals to A, B inverse is B, X inverse is X. In that fashion, A inverse is definitely, it is nothing but, A is nothing but A inverse. A inverse is equals to A, or A is equals to A inverse, something like star, and B here, and B is nothing but B inverse, right? Now I want to operate the first theorem here. So the first theorem, you mentioned something. Sir, we know that X star Y is nothing but X star Y whole inverse is equals to Y inverse star X inverse. I am talking about first theorem, my dear. If G is the given group, this is the theorem I am talking about. If G is the given group, X star Y whole inverse is Y inverse star X inverse. Just ABs, in place of ABs, I have XY, something like this. Just now we proved this theorem, right? Now let us use the same theorem here. Sir, here your Y inverse and X inverse, this is just like Y, sir. This is just like Y, or you can say phi inverse. And this is just like X inverse. So your RHS part is available. From this you can write LHS. LHS is something like this. X into Y whole inverse. My dear, this is X and this is Y. I need to write X into Y whole inverse. X is nothing but B. B is acting as X. B star A whole inverse. Is point clear? We have Y inverse, X inverse. From that I return X inverse, X into Y whole inverse. The product of two elements inverse is equals to the product of inverses of their elements, which are appears in reverse order, right? Sir, here we got B star A. B is one element, A is one element, and I am sure that B star A definitely belongs to G, because B is one element, A is one element, B star A is nothing but it, by using closure property, B star A definitely belongs to given G, and B star A whole inverse is nothing but B star A. Sir, how you can say, sir, B star A whole inverse is nothing but B star A? Yes, my dear, you mentioned every element in the given G is having its own inverse. A inverse is A, B inverse is B, X inverse is X. In similar way, B star A whole inverse is also B star A. Yes, sir, I reached the target, something I got. A star B random elements I have taken in the given G. A star B is equals to B star A for all AB, which means that we have completed the task, something called G is an abelian group. Yeah, therefore we can say that here we got A star B is equals to B star A for all A comma B belongs to G. So hence we can say that given G under operation star is an abelian, right? Is it clear, my dear? So I hope you got the idea. So whenever I have taken this theorem consists two parts. First part is you can conclude something like A square is equals to identity, G is an abelian group, that is one conclusion. And second conclusion, that is something called our previous gate. What is that gate question? You should understand in this way. Yes, sir. In the given structure, the structure is already a group. In that group, if every element is have its own inverse, x inverse is equals to x for every x belongs to G. If that thing happened, definitely the group is going to be abelian. So two theorems are here. I hope you got the proof for these two theorems. And let us go for the remaining properties also. So whatever the properties we have discussed, something about identity and what do you call inverse. Yes. Yeah, let us take the first one. The identity element of a group is unique. Yes, sir. How you are saying the identity element of the group is unique? Let us go for the proof of this theorem in contradiction way. Right? Let us go to the contradiction, just like an indirect proof method. Let us go for negation. Yeah. Sir, we have the statement like the identity element in the group is unique. The identity element is unique. Yeah. Let us take something here. Let us suppose E and E dash are two identity elements in G. My dear, let us suppose there are two identity elements. Either my consideration is true or false, it doesn't matter. Yes, you are saying that identity element is unique, that's okay, fine. But I just taken the contradiction to that statement. I consider there are two identity elements. Yeah, let me take the first statement. If E is an identity element, if E is an identity, then what happens? A star E is equals to A. A star E is equals to E star A is equals to A. Let me write in simple way. A star E is equals to A, or which is equals to E star A for all A belongs to G. Right? And in similar way, if E dash is an identity element, then A star E dash is A, or E dash star A is also A. And which is also happens for every element. So my dear, understand, so this answer is A and this is also A. So which means that A star E is equals to A and A star E dash is equals to A. So you can leave this part and just consider only this area. You can solve in any manner. Let us go with one simple one. That is the point I am saying. So in both cases, the right hand side answer is same. So then the left part must be same. So what do you say? You can say something like this. Therefore, A star E is equals to A star E dash. You can simply say that A can be cancelled like, but actually the cancellation is not possible. Actually, what we are doing is we are applying the cancellation law. And that cancellation law is known as left cancellation law. A is at left side. Na? So let us pre-multiply with A inverse on both sides. So here I am doing pre-multiplication with A inverse on both sides. Right, sir? Pre-multiplication. The above equation appears like this, my dear. A star E is here. And here we have A star E dash. My dear, this is E dash. It is not like a, what do you say, E inverse. It is simply E dash. Right. So here in this equation, what I am doing, I am pre-multiplying with A inverse. So left side pre-multiplying with A inverse like this. And right side also pre-multiplication. So if it is left part, if you take an A inverse, here also A inverse you should take left part. I want to take A inverse right side like this. That is not allowed. That is the meaning of this word pre-multiplication, like A inverse star. Right. Now let us operate, my dear. Yeah, let us apply associative. A star, A inverse star A star E is equals to A inverse star A star E. I am just opening the parenthesis here and I am putting here and here also in same fashion. And A inverse star A, that is nothing but identity. So the identity element, some whatever the identity you have, you got it here. Identity element star E here, and here also identity element star E dash here. Now identity with E is E again, and identity with E dash again E dash. My dear, understand clearly. I started the question with there are two identity elements, but at the end of the process, what I got is that two elements, what are the identity elements you are saying? They are same. So not only two or three, you can take anything, but the identity element in the group is unique, my dear. So don't say that two identity elements, three identity elements exist. And even if the identity element is E in the given group, even in subgroup also the identity element will be same because operation is same now. Whatever you are taking H star is the subgroup of G star. So G star is the group and H under the operation star is the subgroup. Whatever the identity element available in your given G, the same identity element must be available in your subgroup H also. In your subset H, you are applying same operation, same star operation. Then the identity element will be same. It cannot be different, right? Yeah, in similar fashion, I hope you got the idea about inverse also. Yes, let us take something called inverse. Yeah. The inverse of each element, whatever the inverse you take here, the inverse of each element is unique. Yeah, let us understand this concept also. Inverse of each element is unique. So I hope you taken the required things. I think the identity concept E is equals to E dash. I think it is okay, fine. Now in similar way, what I want to say is the inverse of the element, the inverse of any element in group G is unique, my dear. Right. So in similar fashion, how we have taken identity as unique, in same way we can think about inverse also. Let us take something called inverse. Yeah, let us suppose there are two elements which belongs to G. Let A comma B belongs to G. There are two elements. I think even if I take one element also is okay. Yeah, let us take some two elements. A comma B belongs to G. And I want to think that A is having two inverses. Yes, yes. I want to take one more element. Yeah. B, C belongs to G. Yeah, this is fine. Let us suppose, let us suppose element A has two inverses, B and C. My dear, actually A is having only one inverse, that is something called A inverse, unique way. But I am supposing that there are two elements. Two elements are there for the inverse of A. B is one inverse and A is another inverse. According to inverse property, we know the inverse property. Yes. As we know the inverse property, x star y is equals to y star x is equals to identity. X star y is equals to y star x is equals to identity. This is the inverse property we have. Now what I am thinking is A is having two inverses. One inverse is B and another inverse is C. If B is the inverse of A, what should be happen? If B is the inverse of A, if B is the inverse of A, then it has to satisfy the condition like A star B must be equals to identity. Right, sir? And in similar fashion, if C is the identity element, if C is the inverse element, if C is the inverse of A, then you can say that A star C must be equals to identity. Right, sir? Sir, we got two equations. The first equation is A star B is equals to identity. And the second equation A star C is equals to identity. In both the equations, the right side part is same, identity here, here also identity, which means that the left side part must be same. So if you ask me to name the equations, I can label them like this. This is 1 and this is 2, something like this. Right? Sir, from the equations 1 and 2, from equations 1 and 2, the LHS part, whatever we have, A star B is equals to A star C. So when A star B is equals to A star C, you can apply left cancellation law. So you can apply left cancellation law operating on A inverse on both sides, then you will get B and C, right? So I hope you are getting this. Yes, let me write like this. By left cancellation law, it is something like this. A star B is equals to A star C. I am operating with A inverse on both sides. This is A inverse. And here also I am operating with A inverse. Then in the next step, what I will get, my dear? A inverse star A star B, and which is equals to A inverse star A star C. And A inverse star A is nothing but identity, which implies that E star B it is, And in similar fashion, A inverse star A, this area is also identity, E star C. Yeah, fine. And here what we have, E star B is equals to E star C. So E star B is nothing but this is B by using identity property, and this is E star C, this is C. Yeah, I assumed that there are two inverses. B is one inverse, C is another inverse. But end of my process, what I got is both inverses elements, whatever I am saying, B and C are same. B and C are same means the element A is having only one inverse element, that is unique element, either B or C, because both B and C are same. Therefore, you can say that inverse element, inverse of an element in the group is unique. Yeah, my dear, this is the way of analyzing the questions. I considered the properties, and we discussed different properties, and this is the present trend going on in our group theory. So sometimes they ask about generators and cyclic groups and something called either the given structure is what, just like MSQ question. Yes, it is groupoid and also monoid. It is groupoid, semi-group and also monoid. So such type of questions are there. But if we see the recent questions, they are focusing on the properties. So try to be strong in the proof and properties. Minimum you should know the property, and after the property, some students cannot understand. They don't want to by heart the property. They just want the clear cut proof for the property. So here I discussed the proof for the properties, and these proofs helps you, your logical thinking, how we can derive the proof. So whenever we are taking that AB whole inverse is equals to B inverse into A inverse, to prove this one, how I considered X star Y. So this is X, this is Y like. So these type of logical thinking helps you in many areas, my dear. I hope you got the things. And I think you enjoyed the today's session also with group theory concepts. Let me check the messages of yours once. Rahul is asking some question about calculator. Rahul, actually calculator is available in our gate examination. Virtual calculator is available. You can use that one. And Rakesh posted some question like, sir, how much time should I give a particular subject to complete GATE CSE syllabus? Uh, my dear, it is better to you to watch my yesterday's YouTube lecture. Yesterday I have taken the live session. So on that session we discussed many things and strategies. So if you ask me I can say something like you should be very strong in classwork, my dear. First, whatever the class notes you have, you should be good in that class notes. So many of the faculties and many of the people says that simply you should be good in class notes. So what is meant by that? So every model in your class notes must be fixed in your brain. It is not about just solving the question. So some students just refer the notes just like a novel. So it is not a good idea. Yeah, if I refer the question, okay, I got the idea. It's not like that. If you put pen on paper, you can understand the practical problems and you can derive the new things. By practicing the same question n number of times, you should get the idea of the new approach of solving the questions and shortcuts, and you can become strong in that areas. So that is the way of the thing you can say that, sir, I am strong in the class notes. If you are okay with every problem in your class notes, then you can finish almost your 80 to 90% of the task. 80 to 90% of the task is okay. And after class notes, you can refer the materials, prescribed materials, whatever the materials available to you. Let us suppose one of the premier institutes in our India, that is called our EAS. So we have the prescribed textbook for discrete mathematics. So you can go for Kenneth Rosen's and all. So in Rosen's, when you refer the textbook in Rosen's 8th edition or whatever you say, so many things are there, na? Mathematical induction is there, graph theory, more concepts, modular arithmetic, many things are there, but you should understand what is really required in GATE. So by understanding, by referring all the textbooks, we prepared AS material. So if you go through the AS material, that is specifically designed for our GATE CSE students. So you should be strong in ACE materials first. So you can say that our ACE textbook, volume 1, volume 2, bits and bytes, many things are there, na? If you are okay with the textbook concepts of ACE, then you can go for the workbook concepts. I think in workbook you have plenty of questions. Let us suppose you are not good in the area, you are not good in some particular area. So refer the class notes and try to get a very good idea. After getting the idea, try to go for what do you call ACE workbook. In a particular topic, you may have some 50 questions, 70 questions, 100 questions are there. If you are able to solve all the questions, then definitely you can be strong in that topic. So that is the thing you should point, make it off. And after that, after the ACE material, you can go for test series also. Some test series are available, na? Yes, test series. The test is just like analysis. It is just like something called assessment to you. You can understand where you are really in this competitive world. So there are 100 students where you are really. You are just preparing yourself and you are understanding the concepts and you just thinking yourself, yes, I am okay, I am strong. That is not the right way. If you do the assessment test, yes, I am good in this area, I am not good in particular area, this is the area I need to focus more. All these things you required and you can get the solution for all these things by using the test series, right? So my dear, understand, test series is the next level. And after you can go for other things like prescribed textbooks, whatever the standard textbooks we have. If you want to go for if you want to go for more number of questions and more different type of vocabulary, you can go for standard textbooks and you can refer them. And whenever you are doing the test series, almost it is just like one type of revision, right? It is one type of revision. Every concept is triggering in your brain and you are answering the questions like. And after these test series, and every time some students write every day test, one day one test. I don't know how much that idea works. So every day writing the test, even sometimes they don't have the preparation also. Yeah, you need to take a minimum break, my dear. You just take some one test in 3 days, right? In every 3 days, if you take one test, weekly twice, and in this test also, what you should do, let us suppose I missed one question from the pipeline concept in the last test. So this time I need to refer the class notes of computer organization and I should cover that. I did not answer the question from K-Maps last time. I missed one question from Hamming code. And in the next test, I must cover that one, must cover that one. If you cover that concept, then only your score will increase, right? Instead of that, every time you are answering the question, yes, every time I can answer the question from graph theory, but I did not answer the question from group theory. Then how we can say that the score is going to be increased and how you can be different from the other students, right? So if you are slowly cover all areas, untapped areas and untouched areas and different areas, if you cover all these things, yes, you need to cover from the class notes. Most important task is over, that is okay. After most important necessary is okay. But when you want to aim for top rank, like single digit rank or 2-digit rank, if you want to get 600 below rank to aim IITs and all, then you must go for divergent. In that case, you need to focus all other things, my dear. My dear Rahul, so this is the thing you should do. Now you tell me what is the time a student can take in one day. You framed a question, na, sir, how much time I need to spend. So I am not saying the time, I can say you the to-do list. This is the to-do list to do by the student. So if he able to do this one, he can complete the task. Yeah, some students can spend at least 4 hours per day, at least 4 hours per day. And some students can spend at least 8 hours per day. That depends on their IQ level, my dear. That depends on their IQ level. And even if you don't have IQ also, if you have a proper EQ means emotional cohesion. Yes, you want to achieve your target, you want to achieve your goal. If you have very good ambitious, you may not have very good IQ like a topper of the class, but it is not required. IQ is not like an inherent property. Yes, it can be given by some level by the God, but everybody can improve that. It is not at all an impossible task. It is a possible task. If you practice every day, definitely you can improve your IQ. My dear Rahul, understand, if you have very good EQ level, even if you don't have IQ also, if you work hard, definitely you can do the task. And hard work alone doesn't works, and you should do hard work and smart work together. That means some students can open the book and they will prepare hours together. Sometimes they did not receive even some 10% of the subject. That is not the right way. That is not the right way. Even if they prepare 4 hours also, you can prepare for 1 hour. Yes, you can prepare for 1 hour. After 1 hour, you can take some 10 minutes break, 10 minutes break and 10 minutes revision, 10 minutes revision, and again you can go for next 1 hour preparation. So you can follow the cycle in this pattern. Yeah, the even many of the psychologists says that 25 minutes concepts understanding, after 25 minutes, 5 minutes is revision and 5 minutes break is required. So even if in our GATE subject, in 25 minutes, I don't know how much level concept you can cover. You concentratedly prepare for 1 hour first. After 1 hour, you can take a proper time, 10 minutes time for revision. 10 minutes time for revision. Revision is very important. Many of the students thought that the revision is going to be time waste. They want to cover many, not like that, not like that. In revision, if you prepare a short notes, whatever you prepared earlier, so that helps you, that makes you things very easier. So in that 10 minutes revision, you can prepare some short notes and understand the concept in brief way. After 10 minutes, you can go for 10 minutes some break and again concentrate 1 hour to learn the concepts. So this is the way you can follow the cycle, my dear. So even if you prepare 4 hours per day, And if you prepare like this for 3 to 4 months, that preparation is more than enough for GATE. I am talking about completed students. If all your syllabus is completed, if you are okay with this, every day you are actively preparing for 4 hours concentratedly, and you prepared like this for 3 to 4 months. That I saw many students, they cracked the GATE. And some students are saying, sir, even 1 hour, I think Matesh Kumar, someone asked, yes, 1 year is definitely enough time, my dear. 1 year is really enough for GATE, right? Okay, thank you. Thank you very much, students. Thank you for active participation in our session. And that's about our today's class. I hope you enjoyed the today's group theory concepts. And thank you very much for your cooperation. Meet you again. See you and wish you all good luck. Right? Fine. Have a nice day.